Welcome to Module 10, Lesson 3, Generating Equivalent Expressions. So today we're going to talk about how to apply those properties that you've talked about in the past, commutative property, associative, distributive, identity property, and how we're going to use those to create equivalent expressions. We've talked about equivalent ratios, fractions, and things of that nature, and that's when we have two fractions or ratios that don't have the same numbers, but they have the same value. Same idea with expressions. So we're going to talk about how to use those properties to create two equivalent expressions, and then also how to identify when two expressions are equivalent. Right? So here we go. So to start off, what we're going to do is we're going to take these two lists of expressions, and we are going to determine if which ones are equivalent. So one way to do this is to simply choose a value and to substitute that value in for the variable for each of the expressions. So for this one, we chose the value 3. So everywhere that you see an x, we are going to substitute the value 3. And then we are going to see what the expression gives us. So for the first one, for list A, we have 5 times 3 plus 65. 5 times 3, is 15 plus 65 gives us 80. So the first expression would give us 80. And the next expression would be 5 times the quantity 3 plus 1. So I add 3 and 1 and I get 4. And when I do 5 times 4, I get 20. And then I have 1 plus 5 times 3. So I start by doing 5 times 3, which gives me 15. And then I add 1. And I get 16. All right, then I'm going to go through list B and do the same thing. So here I notice that 5 times 3 plus 1, well, that's the same thing as I did here. I just changed the order. I still do 5 times 3 first, and I get 15, and I add 1. And it still gives me 16. Here I have 5 times 3 plus 5. So when I do 5 times 3, I get 15 plus 5 gives me 20. And then here I have 5 times the quantity 13 plus 3. I have to do 13 plus 3 first, which gives me 16. And 16 times 5 gives me 80. All right, so now what I can do is I can look and see that I have pairs of expressions that are equivalent. And I see that my first two expressions that are equivalent are 5 times 3 plus 65 and 5 times the quantity 13 plus 3. My other pair of equivalent expressions are 5 times the quantity 3 plus 1 and 5 times 3 plus 5. And my last set of equivalent expressions are the ones that were just flipped from one another, 1 plus 5 times 3 and 5 times 3 plus 1. All right, so we might not want to just take one number as a good example. So how could I further test for equivalency? Well, it's simple. What I could do is I could continue to plug in different values for the variable and to see if my expressions are still equivalent. In this case, I would still get the same answer, okay, especially since I'm not dealing with exponents. So do I think my expressions in each pair are equivalent? Why or why not? Yes, I do think that they are equivalent, and the reason for that is because if they get the same solution when using the same value for the variable, it would make sense that they would always be equivalent. So when I put in a 3 in one expression and put in a 3 in the other expression and I get the same answer, it would make sense that those expressions, even though they look different, since they give me the same answer, it would make sense that those expressions would be equivalent. Much like our fractions, so like 2/4 and 1/2. Even though they look different, they both have the same value. If I were to say that, Ricky ate 2/4 of the pizza and Johnny ate half of the pizza, they still ate the same amount of pizza even though I said it differently for both people. All right? So we have to remember that just because they look different doesn't necessarily mean that they have different values. We have to do a little bit of math and a little bit of computing to figure out if they have equivalent values. And equivalent doesn't mean that they look the same. Equivalent means that when we plug in a value, that it will spit out the same answer. So think of it as a machine. When I put in 3, this machine gave me 80, and this machine gave me 80, so they are equivalent machines. All right, so Lisa evaluated the expressions 2x and x squared for x equals 2 and found that both expressions are equal to 4. So Lisa concluded that 2x and x squared are equivalent expressions. Now, you have to remember that 2x does not mean 2x. So when we plug in the 2, it does not become 22. It becomes 2 times x. 2x means 2 times x. So in this case, yes, both of them give us 4, but let's think of a different number that we could plug in because we said that's another way to check for equivalency. So I decided I'm going to go ahead and plug in the number 3. Well, when I plugged in the number 3, I find that 2 times 3 would give me 6. But I also know that 3 squared would be 9. And I know that 6 and 9 are not equal. So since 6 and 9 are not equal, that tells me that 2x and x squared cannot be equivalent. So I know that, and I actually should put equivalent here, not equal. So I know that 2x and x squared cannot be equivalent. Equivalent. There we go. Much better. All right, so let's move along. On here, what I did was I changed all these pluses to x's, except for on my squares. It made it a little bit easier for me, so if it helps you, you can go ahead and do that. Having all the same signs on the tiles really made it confusing for me. So when it was talking about x tiles, I literally put x's on them. Makes more sense to me. So when you're drawing a model, this really can help you out in looking at equivalencies. So if we're modeling the expression 3 times the quantity x plus 2, and using that to determine if it's equivalent to 3 times x plus 6, we have to think of what these two things mean. So this means that I have 3 groups of x plus 2. So I'm actually going to box this off here. I think that'll help us out. So I have 3 groups of x plus 2. So I have x and 2, and x and 2, and x and 2. So 3 groups of x plus 2. Right? Now in doing that, if I look at my totals, I see that in that grouping, I have a total of 3 x's and I have a total of 6 1 tiles. Okay, so I have a total of 3 x tiles and a total of 6 1 tiles. Now, when I look at 3 times x plus 6, that tells me that I have 3 x tiles and 6 1 tiles. So again, even though my expression looks different, I have the same amount of tiles. I have 3 x tiles and 6 1 tiles. So when I'm looking to see if the expressions are equivalent, we can see by the model that yes, they are equivalent. And they're equivalent because they both have 3 x tiles and 6 1 tiles. So drawing these models can definitely help you, but you have to understand what the expression means. So what we're going to do is we're going to take a look at number 2, and we're going to use these tiles to determine if 2 times x plus 3 is equivalent to 2 times x plus 3. So again, remember, this means 2 groups of x plus 3. So 2 groups of x plus 3 means you have 2 groups of x plus 3. So there's one group of x plus 3, and then here's another group of x plus 3. So again, here's one group of x plus 3, and here's another group of x plus 3. Okay, so then now let's draw the other one. The other one tells us that we have 2x's plus 3. So here I have 2x's, and then I have 3 1's. So 2x's, and I have 3 1's. Well, if I look at this, I do have 2x's, but here I have 1, 2, 3, 4, 5, 6 1 tiles, and here I only have 1, 2, 3. So here I can already see that in 2 times the quantity x plus 3 and in 2x plus 3, they're not equivalent. Because in here I have 2x tiles and 6 1 tiles, but in the other one I have 2x tiles and only 3 1 tiles. So when my number of tiles doesn't match, my expressions cannot be equivalent. All right, so you have your list of properties listed above example 1. I strongly encourage you to write down and practice these properties. And I am actually going to have you put them in your vocabulary notebook again to make sure that you're practicing them. But you are going to have to use them, and you are actually going to have to tell me which ones you used to help you solve problems. So please, please, please make sure you're practicing your properties. We are going to do the example 1 and all the your turns together. So we're looking at example 1, and it's really simple. We're going to create an expression that's equivalent to x plus 3. And to do so, we have to look at look at what operation we're using. Well, we're using addition. When we're using addition, that allows us to use a lot of different properties. We can use the commutative property of addition, the associative property of addition. We can use the identity property of addition. But in this case, we don't have any groupings, so we can't use associative. We're not using 0, so we can't use the identity. But we can move our numbers around. So what I can do is I have x plus 3, and I can move those numbers around and make an equivalent expression of 3 plus x. And I did that using the commutative property of addition. Okay, and again, I couldn't use the associative because there's no groupings, and I couldn't use the identity property because of the fact that we're not using 0. So let's look at the your turn. Here we're using multiplication. So multiplication does allow us again to use associative and commutative, identity property. It also allows us to use the distributive property. Now in this case, we don't need to distribute the C to the A and the B. That's not, I mean, we could use that to make a different one, but we're going to start simple, and we're actually going to, because we have a grouping here, we have the parentheses, we're going to use the associative property. Right? And the associative property, again, allows us to move our grouping. So here we have A and B that are grouped together. So instead of multiplying A times B and then multiplying C, we're going to change it to A times the quantity B plus C. Now you have made an equivalent expression to the quantity AB times C and changing it to A times the quantity B plus C. Simple, I know, but it gives us a good start. This one's a little different. Yes, we could use the commutative property and just move our numbers around, but I actually want us to get some practice with the distributive property. So if you look here, you'll notice that we have two things in common. We have a y and a y. So what that means is we can pull the y, and they're both being multiplied by the 3 and the 4. So what that means is we can actually pull both of those numbers out, okay, and use the distributive property to make our equivalent expression. So what we're going to do is we're going to pull the y to the outside, and then we're going to put a parenthesis. Then we're going to keep the 3, and put it on the inside of the parenthesis. And then we're going to keep our addition sign because we're adding. And then we're going to use the 4 on the inside. So what we did was we took that multiplication, and instead of multiplying the y by the 3 and the 4, we took it to the outside and we're multiplying it at the end. And we'll do a little bit in class to show, to explain a little bit more why this will work. But for right now, I want you to get the practice with how to do it, and we'll work more in class with the why it works. All right, and then here again, we have no groupings. We don't have any connections here, so we can use the commutative property, but of multiplication this time, to just move our numbers around. So 6 times 7 is equivalent to the expression 7 times 6. Really simple stuff, I know, but it's leading us to the more complicated pieces ahead. And trust me, once you hit 7th grade, we build on this even more. So please make sure that you're getting your practice and make sure that you're understanding how these properties work. All right, so we're going to use our properties of our and operations to determine if the expressions are equivalent. So the distributive property is a huge part of this process. The distributive property, so you have to think of it, I always like to talk about a paperboy, and I know this goes back to when paperboys were actually on bicycles and distributing the paper, but you have to think of a paperboy who used to take the paper and he used to, throw it onto the lawn, house to house to house. Well, here's your paperboy, and he's distributing the paper to house X and house 2, right? He has to distribute the paper to everybody or he doesn't get paid, right? So remember that. When you use the distributive property, it has to be distributed to everything inside the parentheses. So the paperboy has to distribute the paper to everybody in the neighborhood or he doesn't get paid. The number outside the parentheses has to get distributed to everything inside the parentheses or your answer is incorrect. All right, so when you distribute, you're using multiplication. Remember, a number connected to parentheses means multiplication. So 3 distributed to the x will turn into 3 times x. And then 3 distributed to the 2 means 3 times 2, which is 6. And then this subtraction sign stays the same. That just stays right where it is because we're still going to subtract those two quantities. So now this 3 times the quantity x minus 2 changed to 3x minus 6. Well, is 3x minus 6 equivalent to 3x minus 6? They're the same thing, so yes, these expressions are equivalent. So basically what you're doing is you're seeing, can I manipulate this expression to make it the same as the other one? If so, then they are equivalent. All right, so let's give this one a shot. I know that it's fractions. Don't let it freak you out. It's half. Remember, when you multiply by half, you're literally taking half of something. So again, the paperboy has to distribute to everybody in the neighborhood. Otherwise, he doesn't get paid. So he has to distribute to 4 and to x. Excuse me. All right, and when he does that, half times 4 is 2. Half times x is half x. Well, is 2 plus 1/2 x the same thing as 2 plus x? In this case, the answer is no. So these expressions are not equivalent. All right, so now that we've gone over those two examples, what I would like you to do is I would like you to try numbers 6 and 7 on your own, just 6 and 7. And when you come back, we'll check your answers. All right, so now that you've tried 6 and 7 on your own, you should have come up with that 6x minus 10 was not equivalent, and you used the distributive property to figure that out. So 2 was distributed to 3x and to 5. That's how you got it, the 6x minus 10, and found that they aren't equivalent. Here, the 2 minus 2 would give you 0. 0 plus 5x. Any number plus 0 allows the number to stay the same. That's the identity property of addition. So that tells us, so 0 plus 5x tells us that 5x and 5x are going to be equivalent. So yes, these two expressions are equivalent. So now if you look at number 8, Jamal bought 2 packs of stickers and 8 individual stickers. So 2 packs of stickers, and we're going to use X to represent the number of stickers in a pack, and we're going to write an expression to represent the number of stickers Jamal bought. So if he bought 2 packs with X amount in each, plus the 8 extra stickers, there's your expression. And we want to know if that's equivalent to 2 times 4 plus X, or 2 times the quantity 4 plus X. So again, you have to look at the fact that this is 2 groups of 4 plus X. So I have 4 ones and an X, and 4 ones and an X, giving me 2 X tiles. That's an X. I'm doing my best to write an X here. And 4 1 tiles. Here I have 2x plus 8. So again, I have 2x tiles. And I'm sorry, this isn't 4 1 tiles. This is actually 4 1 tiles here and 4 1 tiles here. So I actually have 8 1 tiles. And then over here, I have 8 1 tiles. So this model shows me that yes, these two expressions are equivalent. All right, combining like terms. So as you saw before, like terms are terms that have the same variable, and this includes variables with exponents, okay, or terms that don't have variables. So we're going to take a look at how this works. You cannot combine terms that do not have the same variables or terms that have variables with terms that do not have variables. You cannot combine a term that has a variable and an exponent with a term that has a variable and no exponent. Literally, your terms have to look almost exactly the same. The only thing that can be different about them is the coefficient. So for example, here you have 6x squared minus 4x squared. The things that you have that are the same, I'm going to try to make this really small so it doesn't get too overwhelming. Your x is the same and your x is the same. That's great, but you also have to notice that there is a squared. If this was squared and this one wasn't, you could not combine them. But because this is x squared and this is x squared, you can combine these terms. It does not matter that your coefficients are two different numbers. So you combine them using the terms or using the operation that is given to you. So in this case, the operation is subtraction, and you're doing 6 minus 4. 6 minus 4 is 2, and then you keep your variable and the exponent, so you get 2x squared. All right. Plain and simple on that one, and now we're going to get a little bit more complicated. Now you actually have to follow and use those properties and follow those order of operations. So the first thing we're going to do is we have to get rid of these parentheses. All right, so to get rid of those parentheses, we got to distribute to the neighborhood again. So we have 2 times b plus 2 times 5a. All right, and when we do that, we still have 3a plus, now instead of having those parentheses, we have 2 times b plus 2 times 5 is 10, and we have a. But now what we're going to do, because you notice we have a as a variable and we have b as a variable. So what we're going to do is we're going to use the commutative property of addition, since we're adding all these terms, and we're going to get it so that way our like variables or our like terms are all together. So I'm going to use the commutative property to move my terms around. My terms are all the different pieces here. So like 3a is a term, 2b is a term, 10a is a term. Okay, so I'm going to move it around to put my coefficients with the variable a together. So like 3a plus 10a plus 2b. It's going to make it a little bit easier for me when I go to combine my like terms. All right, so now I can combine 3a and 10a. And the reason I can combine them is because they're like terms, because both of them have a as a variable. However, I cannot combine them with 2b because the variable here is b and these have a variable of a. So when I do that, I do 3 plus 10, which is 13, and then I just bring down plus 2b, and I have created my equivalent expression. Now here, I don't have any parentheses that I have to get rid of, so I don't have to use the distributive property. However, you'll notice I have y as a variable, and I have a like term, even though this one does not have a coefficient and this one does. And technically this does have a coefficient, it's just a coefficient of 1, and you just can't see it. So I have two like terms there, and then I also have x and x. So what I want to do here is I do want to rearrange my numbers so that way I can make it easier to combine my like terms. But you also have to remember I have subtraction here. So I can't move my 7x. But I can move my y, my 11x, and my 7y. But I have to keep my subtraction and my 7x where they are. All right? For now, when you get further on into your math career, you'll understand that we can do some little tricky stuff and we can move that around. All right, but for right now, we are going to take these two and we're actually going to flip them, because if I do that, that'll take 7y and put it by y, and 11x and put it by 7x. So then I get y plus 7y plus 11x minus 7x. And now I can go ahead and combine like terms. Well, y plus 7y would give me 8y, and 11x minus 7y would give me 4x. So my simplified expression would be 8y plus 4x. Again, you'll want to take this slowly and show all of your work. Go step by step. Do not try to do this in your head, and do not try to skip steps. That is where students make their mistakes, and that is where things get messy. All right, so what I'd like you to do is I would like you to go through and combine your like terms and solve to simplify, or not solve, but I'd like you to simplify and create equivalent expressions for numbers 9 through 12. When you come back, we'll check your answers. All right, so you should have found that for number 9, you got 5y, because 8 minus 3 is 5. That one was pretty simple. Here you should have found that you got 10x squared minus 4, because you distribute the 4 to the x squared and to the 1. And so I can type this one out for you. So it would have been 6x squared plus 4x squared minus 4. Then when you combine it, you can combine 6x squared and 4x squared because they have the same variables that have the same exponents. So we would have gotten 10x squared, squared, not at. And then minus 4 because there's nothing to combine the 4 with. All right. Here you could combine 4a to the 5th and 2a to the 5th by subtracting, so you get 2a to the 5th, and you can add 4b plus b and get 5b. Here, The only things that you could combine were 14 and 12 by subtracting, and you would have gotten 8m plus 2 plus 4n. Right? So at this point, you're going to go ahead and do your guided practice. Remember, you are doing your guided practice on Go Math. So you are doing it online. Write that nice and big. Do it on Go Math. This page here is for extra practice. All right. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.